Oh my god, what the hell? Is everything fine? I think so. Hey, Andrew. Yeah, so while you're here, and I mean, it's super late for you, so thanks for being here. Yeah. Hey, so before you go to bed, basically, what I'm trying to do now, with MIR on x86-64 is adding like those silly tests. So I'm kind of refactoring somewhat how we pass things around. Like normally we would have, for example, MIR move. I actually split that into implementation as well. Like when it comes to actually catching errors, I'm still working on this. Just a proof of concept now. But basically the MIR move is taking everything as an argument to a function, so that I can actually mock it in, wait a sec, in the test suite. Because it's actually kind of difficult to work out whether what I'm doing makes sense. And then trying to debug it at runtime is quite difficult in some cases because the generated assembly can be quite big. So I ended up doing something like this. I also decided that I'm going to try out, basically MIR is going to, emit will throw an error, like a hard error, that as an error message we're going to pass up if there is, for example, a size mismatch between two registers. Rather than promoting or demoting a register to match the size, because I think that might be kind of dangerous, I think it's better to be explicit and then fix that in the actual code gen, then do some black magic here in the emit. I don't know if you agree, but that's the gist nowadays, at the moment. So that's what I'm trying to work out. So hey everyone. So yesterday we were working on the MIR refactoring, and we're gonna carry on today as well. I did a few enhancements since the stream yesterday. I put some of the stuff in actually helper test functions. We have test emit single success, where we expect the result to be a success, and then we compare with a given expected encoding. And then we have also test emit single fail, which basically, so this wasn't there before, but I decided that it's better to throw an error message straight away for cases that should never happen, like a mismatch in register sizes, where you actually move one register into another. That's a hard error as far as I know. This instruction should not exist. How it actually behaves with the CPU, I have no idea. That might be something that's worth investigating. But anyway, so the simple one is handled. Oh, and I also, before I forget, if you remember from yesterday, move was also implemented using mir arithmetic, like basically the same code structure as arithmetic instructions, but I actually moved it out because there was a case where they were diverging, and it kind of didn't make sense to like. I think it's clean, even though we repeat ourselves for these. I think for now at least, it's better to be more verbose and have some repetition than trying to be clever and actually have everything refactored like properly, because we might actually change whatever in the future, and this might actually bite us in the ass. So arithmetic instructions are separate from move now, and then inside move we actually don't have the same problem as last time, where we had some crazy if statements here, switching opcode, switching even which direction the instruction is, because this should be, I think, r/m, so the memory operand should go first. Oh wait, yeah, it used to be like for arithmetic, I think this is the MR, so memory operand and then the register, but here is the opposite way. Now, this is also the tricky one. I don't know why it's here. I think like this, we already have that one. We have that exact encoding for flags 0b00. Oh no, wait. Okay, so this is reversed. We have mr, and for 0b11 we have rm. So I want to actually work out why and why that matters. I actually thought that it shouldn't, but we'll see. The resultant encoding differs only by 1 byte. Oh, hi Venet, hello. By 1 byte. So so it's interesting. I don't know why I added this. Not on Mac today. No, it's like yesterday I was on NixOS. So I'm actually doing x86-64, and since this doesn't require a Mac OS, I prefer to work on Linux whenever I can. So unless I'm fixing stuff on a Mac, which is quite a lot these days. So, but I will do some Mac stuff too in the future for sure. Maybe even some linker optimization passes. That's gonna be a cool learning experience for me too, because I've never done those. So, so yeah. Okay, right. So let's get back to adding tests. Vim on Kitty. Yes, it is. Cool, right? Oh yeah, it's insane. It's so fast. It's very responsive. I love it. I switched everywhere to Kitty. Oh really, Andrew? Thank you. But actually, that's not true. I don't feel comfortable on Windows at all. So that's one thing I need to work on. I don't even have an installation at hand. I mean, I do, but it's I use the 16-inch Intel MacBook in you know, the what's it called, bootcamp mode, I think, right? You have Windows side by side with Mac OS, and I thought, like, well, instead of buying a new machine, I might repurpose this Intel Mac, which is pretty crap when it comes to running Mac, but it's okay when it comes to running Windows. So so I'll do, I promised to actually do more Windows dev as well, but I feel least comfortable on Windows, which is kind of surprising, since I did a lot of shim layer stuff for WASD on Windows actually, but I was doing that in a VM and then learning how Windows Cisco interface works. I was like, wow. Yes, it is. I love the fact that actually Specs is using, that Martin is using Windows as his main dev environment. That's pretty sweet. That's why he's gonna be my rubber duck when it comes to the linker. I'll be asking him, hey, does that make sense? Or how do you do this and stuff? Already? I've not seen his batch files. I need to have a look. Okay, so let's try and do, what is it? Moving a memory operand. So basically we have a source register that's scaled by some offset, and we basically dereference memory immediately, instead of loading that into register and then dereferencing this. So we're immediately dereferencing that in and passing it, moving it into a destination register. So that's what we want to test here. So we don't need the mock stuff anymore because I got rid of that. So let's start with some success, and then we will be adding some failures too, because there are places where this will be inevitable. I just need to work out when it makes sense and when it doesn't. I think sometimes you can have a mismatch. I think for memory operands, actually, you can have a mismatch in register sizes on both sides, because I think, can you? Actually, let's have a look. So what I mean here is that's gonna be something like, I don't know, let's say 16. But then if I do that, would that make sense? Oh, x86, yeah. So it does, okay. Okay, so in this case, it seems that we can actually use, so basically this is a 32-bit size register. Okay, we can use a 32-bit size register to calculate the offset from So just 4 bytes plus that offset. But then the memory operand itself will match the size of the destination register. Okay, interesting. And that you would do that because allocate is basically replacing b table with a raw pointer or what? This article also confuses me a bit. Oh yeah, I mean, if Andrew is still there, that would be cool if he actually explained this. I didn't really investigate that yet, so I have the article open somewhere, but I still need to read it. Right, if we do this, 1, 2, 3, 4 bytes, and that one gives you 5? Oh shit, what is the 67 even? This is some black magic. Yeah, it's actually pretty good, Andrew. This website, although as you will, like, I'm pretty sure today I will have to reach out to the actual manual because this is just a shorthand, and it actually only makes sense when you kind of went through all the different encodings, what the molar m byte is. I don't think there's any description of the scale index base byte at all here, so that has to be taken from the manual. But anyway, yeah, it's pretty useful. However, I have no idea what the 67 is. And the interesting thing is, this is actually preceding the rex byte. Ta-da! Maybe it doesn't make sense then. What the hell? Okay, that makes sense. I want in one volume. Yeah. Okay, everybody, if you want to have a complete guide to AMD 64 ISA, this is it. Oh, I'm sorry, and I was wrong. It's only 3,000 pages. So obviously you didn't have to go through everything. And there are some obscure things like, what was it called? X87, I think. God knows what that is. I have no idea. I need to look this up at some point. I'm not even going to go there at the moment. Right, where was this? We had syntax. Do you have memory operands spelled out like this? Section 2.2. Memory addressing, yeah, that's a rex byte, that's fine. Oh yeah, see? Scale index base. Okay, extending, displacements, immediates. What? X87 is when you run C++ code on x86? Are you kidding me? Wow. This is gonna be great. Okay, you're kidding. Okay, good. I thought you were, and I was like, what? Registers. Yeah, okay, that's not very helpful at all. Right, manual. Oh wait, it's x87 is a floating point thing. For a moment, Lenny face doesn't work. Oh wait, it was. What would you have to specify to get Lenny face? Is that the emoticon that you basically wrote down by hand? The first message, is that it? Prefix, molarm, SIB, or SIB. Ah, perfect. Right. Mob. Mov. Okay, everything starts with one opcode, that's fine. Okay, this is, so I wonder if this is a bug when you specify EBP. What if you specify, was it RBP, BB, was it just BP? No. Damn, I can't remember. X86 and where do we have it in bits? I think bits. No, not like that. Shit. Code gen, was it R? Yes, it was an ARC. Okay, x86 64. Okay, bits. There we go. It's RBP, EBP. There's a BP. Okay, so that's a mistake. I wonder if this is a bug. Like this. That doesn't make any sense at all. Maybe it isn't. Maybe it's some kind of an extension. Right, okay, we'll go back to it. This is interesting. I wonder what the 67 is. I can't recall anywhere you have to prefix with something else. That's not Rex byte. Interesting. Anyway, let's go back to adding some tests. So we're gonna assume that you have to have the same sizes, otherwise it's gonna complain. And I think this is fine actually. So we have tag v1 ops, and then we are testing, what is it? Memory operand into a register. Oh, okay. So reg1, actually let's try something else. Like let's try RCX for now. Let's go with RBP, why not? So this is the destination register will be RCX, the source register will be RBP, flags will be 0B01, I think, just to be extra sure. MIR, yes, we want that case, so this is 0B01, okay, cool, that's the encoding. So we can encode now. And then data, we want to scale. So we need some immediate, let's go with the fancy 16, why not? Okay, and then we need, in the test function, we need what we do expect. So let's have a look in here. So we want a move into RCX. Like so. So there we go, it's 40. Oh, actually we can copy that stuff over. So it's 48 8B 4D10. And this should be, oh, by the way, this text here, the actual disassembly, like in a text format, is just so that when, because I added like a custom test function for equal, I think, hex strings, I called it. If it's going to be useful, we can actually push it into libstud and into the testing module, but for now, just leave it here. And basically, it's going to print this. If there is an error or there's a mismatch, we're going to see which case failed. So that's actually easier to debug rather than commenting stuff out. So we have RCX, we have RBP plus 0x10. And we don't need that anymore here. Oh, this is actually looking good. Might as well do that here. And it's pretty readable anyway. Yeah, it's pretty good. Awesome. Right, okay. So we've got this. Let's have a look. I think we might actually have to, I need to do that as well. I need to fix some of this stuff. I think, okay, the cases are disabled for now, which is great, because we will be tweaking this stuff quite a bit. So we will break stage 2. But the point, so basically the plan of action here is to get the basic unit test actually working, so that we can have a good idea of what we expect with each MIR instruction. You know, what's going to be emitted to, and then after we have that, we can then tweak or fix, in fact, the actual code gen. And then if anything else is failing, we can actually investigate the failing test cases one by one. Oh, excellent. And then work out what the hell is going on. Excellent. Okay, so that works. So we have. Oh yeah, we probably should do that one as well. Actually, so this is move an immediate directly into register, and that's going to be interesting. Is there any size consideration here? Yes, there is. Okay, so if it's, oh, let's have a look. Actually, that's interesting. So this is where's my move immediate? There we go. Oh, is that the one I was missing before? Yeah. Okay, this, I think this is the high byte, is it? I think so. It's 16 bits register, and then you can either access the low 8 bytes, which is the AL, BL, and so on, or you can actually access the high byte as well, which is the AH, BH, and stuff. I'm gonna deal with this later. Obviously, we should definitely have it handled, because I think this is we even wait. Yeah, I think it's. Oh, yeah. Right, if there is no rex prefix, you can actually you can address the high byte. If there is a rex prefix, you are not allowed to. I guess the encoding gets messed up if you do that. Okay, cool. So depending on the immediate, you can either have. Okay, so we should be potentially, I think, able to push. Let's say what is going to happen now? RCX, and then let's say 0, 10. That's extended to 32 bits, 4 bytes. Okay, and then let's go down. Still 32. Right, okay, 64, 32, now it's 16. We actually have only 16 bytes here. I don't think we do that. Huh, we don't. Okay, something we'll need to investigate, I guess. Cool, let's do that as well. So it's gonna be destination register and then immediate. Actually, let's call it immediate only, not necessarily 32. Test, emit, single, success. I don't know about you guys, but this is going great. For the first time in a long while, I'm getting some clarity on how this should work, which is amazing. We want to register, we don't actually need any flags, so we just want to register. And I think this is very important to get right up front, because as I said, without this, if we actually want to, like, if we then battle the code gen and you know, air into MIR and then MIR into emit, a lot of things can go wrong, and actually chasing it is kind of difficult. But when we are sure that actually emit is correctly emitting MIR into correct encoding, we're almost there, and then we can actually focus on other things like register allocation. Yeah, register allocation, and then things like properly reducing jumper locations to like the smallest encoding possible. This is going to come later. This is actually after emit. I think the way it's currently done, my idea was to do it like we do export try in Mako, that we then recursively start reducing. I think. Yeah, I'll need to go back to it. Anyway, and then after this, I think it's zig test. Pretty sweet. Okay, I think 16 should be fine even for, wait, what is this? Is it like this? Yes, it is. Oh, perfect. Perfect test case. Okay. So we definitely want this. Because we need 10, like actually 16 extended to 4 bytes, and this is going to be for 64 byte case. Now it's RCX and it's wide, so we can immediately say this is going to be 48 for the Rex prefix, and then we might actually try it, write it out by hand. What is the op? And the op for this is C7, so C7, and I think that's us. There is no other magic here, I don't think. Wait, this is RCX. Then it's going to be extended to. Actually, this gets extended to 64 bytes, 64 bits. Sorry. But the actual encoding assumes that we can only pass 32 bits. If you want to pass 64-bit immediate directly, you have to use moveabs, which is a different instruction altogether. And we're gonna get to it soonish. Okay, so let's verify. So we have here RCX, and this is 48 C7. Oh, there is a C1. Interesting. I wonder what the C1 is. Has to be the mod RM byte or SIB. No, don't. Let's have a quick look. Temple. What was the C1? Yes, we do have a mod RM direct. Okay. And then we encode the immediate. Oh, there is, yes, immediate 16. I think this is missing here. But let's give it a minute. Okay, let's try this out. I have to say, like, this is obviously slower than the M1, because M1 I think has got the best single-threaded performance. Sorry, out of all the chips that are out there at the moment. But the AMD Ryzen is really working very well in general. Like, I find it a lot faster than Intel. Maybe Andrew, so Andrew, I think Andrew, you are running, if Andrew is still there, you're running on i9 on your Dell. Do I remember right? So you can actually say whether it's still here. Yeah, okay. Are you using i9 on your Dell, on your NixOS? Oh, obviously M1 is beating the Ryzen, but Ryzen is in my experience is much better than the Intel i9 that I have in the MacBook, but that might be just the MacBook. Okay, this is passing, sweet. And I was just curious if you have the same experience, or how do you How do you perceive your i9 on yeah, okay, that's a pretty beefy i9 on your Dell. Oh, nice. Okay. Yeah. See, so this is like crap. So this is only the MacBook thing. That's the problem with the Intel. Oh man, we've been cheated. How about the battery life? Can you actually run on battery on your laptop? Is it okay? Or is the battery dying after like, I don't know, 15 minutes or something? I'm just kidding, but I'd be curious to know what it's like. Oh, okay. So sometimes I'm actually working on my Linux laptop, the AMD one, not plugged in, and it's actually doing really well. It can actually, I can work for 6-7 hours straight. Obviously the performance is dropping, but okay, 4 hours, yeah, that's okay. I thought it was something ridiculous like 2 hours and that's it. Where were we? Oh, I did encoding. We actually don't need the Rex byte anymore here. Now though, no, we don't, right? No, and I think this is one byte shy of what it was here. Okay, this is B9 now. Fair enough. It's actually 2 bytes less. Huh. B9. Oh my god, what is this OI? Okay, let's try it out. This is definitely gonna fail because I don't think I implemented like this. Let's see what the heck is happening here. Oops. Oh, this is gonna be also the moment when I showcase you the very primitive equal hex strings, I think, helper function. It's kind of based on the equal strings helper from the testing module, but it should show us exactly which byte is different. Da, da, da. Come on, come on, come on. Oh, and I didn't print anything, I don't think. Well, this is annoying. Why that is, I wonder. Chart the digit, but this is far too far in the lib. Stood. YAML? Why the hell do we have YAML? Oh, because we test for, okay. I think we don't actually want to do that immediately. I think we want to do it as part of the actual comparison, because I think then we're gonna have the first differing byte printed out together with the rest of the actual encoding, which would be easier for analysis. Yes. Okay. So let's actually have a look. If I copy this stuff over into this fancy online disassembler. Fancy that. You can actually use that too. So I wonder. Is that on purpose that you have so many differences? So many different opcodes? Is there a difference here? Oh, it's just shorter, right? Because this is just opcode plus the actual register will want to push stuff in, and then the immediate. Whereas here, we're wasting 1 byte. Okay, let's take a note of that. You don't want that. Let's take a note. Maybe in test. And then coding was the OI, which is the opcode plus RD, then immediate. That's 8, 16, 32. So we would get B9. Instead of actually consuming 1 more byte, but that's okay. We are fine with this for now. No, I just want 1. Yes. Okay. So this should work, right? Yeah. Yes, I'm curious actually, how are you guys enjoying this? Oh, by the way, this is pretty much, in my experience, this is what working on CodeGen looks like. Actually lowering like higher level instructions like analyzed IR, that's air in our case, or middle level IR, which is MIR, into actual machine code. That's what it looks like in my experience. It gets way more interesting later. Interesting, by interesting I mean things actually break in ways that are like, you can't even fathom like in how many ways it can break, and it does. And then chasing that stuff is a lot of fun. Like basically I was gonna say waste, but you don't actually waste. You just spend the entire day on just looking up, like basically just doing dumps and then reducing, having a look where in which instruction things have changed and why. Oh, right. Thank you, Andrew. Skip 98. Okay, cool. I will do. Yeah, I keep forgetting about this stuff that we can actually build. The test suite or stage 2 with things like disabled. I just keep forgetting to do that. So, right. Skip compilers. Yeah. Oh, wait, but okay. I actually have them commented out because I don't want to run anything but that test suite, because when I run the entire test suite, they will fail because I'll be tweaking. I'm kind of going from the back, from the back to the front. Okay, thank you. Ooh, Outcross is asking what's the Zig's code covered by the test. So that's an excellent question. And do you mean like the standard library, or do you mean the compiler? because the compiler, I think we have a very the compiler, we have a very good test suite, I think. I mean, obviously it's not complete, not even close, but it's really good. In general, our test suite is really good. I was actually using that one as the main test suite for the linker when I was working on it, and you'd be surprised, but it was actually nailing. Hi Nipsey. I mean, look. Yeah, I was using it as a test suite for the linker, the ellipse to tests, including the behavior tests and even the compiler tests. And you'll be surprised, but it actually covers a lot. There are some edge cases that are not covered, but in general, it's really good. I think Andrew was laughing, and actually he was laughing, but it is true that when new LVM releases out, we tend to find the bugs with our test suite. Basically, like almost immediately, there's things like miscompilation errors and things like that. So this is pretty funny, right? And it's getting better. Like I'm gonna be at some point. I will be working on. I already started this work on. I think I even streamed some of it on the linker tests. So I'll be extending. Yeah, we've been averaging 4 regressions LVM on every time they cut. Yeah, exactly. That's what Andrew said. Yeah. And I'll be working on the more verbose, more complete linker tests to handle all the edge cases, but in a way that's actually more extensible. So that you can use it with any linker that you write. So for example, Luke will be able to use that to test his linker, which will be, and that's my goal, right? You write a new backend, new linker, you just stick it in and then you test some of the stuff. You add more tests and it should be easy. Oh, and it should also test the watch mode incremental, like in binary patching too, which we kind of do. There are a few things that we don't have, even though we do support it. For Mako, for example, we are able to do in-place binary patching together with linking in object files, and that should be added. So I think this will be a byproduct of my changes to the stage 2 test harness. But yeah, so stay tuned. I mean, it's gonna happen soonish. Right, I don't want to disassemble. I want to do, or do I want to disassemble? Wait, maybe is that gonna be okay? Nope. Jesus, that's not right at all. Can we work it out here? So wait, we want that one. We want C7. We want C7, correct. So this stays C7 as it was. Oh, shoot. I wonder if this is actually possible without extending that to 32 bits. So basically this is wasting 3 bytes, if I'm correct. Let me have a look at my cheat sheet for modRM, see if we can figure this out. No displacement, 1 byte, 4 bytes. We want, I think, register addressing mode. That would be direct. Mod RM direct, I think. There we go. Okay, so modRM is 0. Is it 0? I think it should be 0. It is 0. Okay, this is the wide version, so not 16 bits. Okay. and this is it. And this is the data. Okay, so this is, yeah, register addressing mode. Cool. So in print, so this should yield the same result. How come it's not being accepted there? Right, okay, let's have a look. So oh, what is this? We don't want that. Because this, everything is a move here. Right, okay, so if this is the case, and then that's C7, but actually C7 for is C6. Oh, but this is +2, right? So this should be -1. Yeah, I think we're gonna have a separate code path for move compared to the other arithmetic instructions. I think that makes sense. Too many if statements like this, and then you're in for a lot of trouble. That was a mistake on my part. Right, opcode is 1 byte, and it's OPC again. Then it's modern direct because it's register addressing mode, and then we have modern, which is actually 0 here. So that's 3 bits. No, it's 2 bits, then 3 bits, and then we have ops red 1 low ID. Unused function parameter 885. Huh. No, don't need that, obviously. Oh, which one? Oh, here, right, okay. My move. Right, okay, but I think we need to fix that here because we will never hit this case. Where is it? Ah, that one. Implementation, we will never hit that stuff. No move. Okay, excellent, right. So this is incorrect, I believe, as we checked a minute ago, but let's try this nonetheless. See what we produce. Ah, and Andrew said the skip. Wait, where is it? Oh, non-native. The skip compile. I guess it's good to get into the habit of doing this. I know what you mean. Look, D was only, yeah. Oh, it's C6. Uh-oh, what did I do? I think I messed something up. Let's see. Oh, because we're immediately entering this bit. So this is incorrect as well, because this depends on the size. So here's a conundrum. Or maybe this should be actually done in the helper instead. So I'm thinking, because this is actually doing register promotion demotion here, maybe it shouldn't be like this. Maybe what we should do, we should accept the register, and then what the size is to get if we need the rex byte at all. Because if the size is less than 64 bits and there is no, and it's not extended, we don't need the rex byte. So that disappears. And then instead of actually matching on size of the immediate, we would actually match on size of the register. And then depending on that, we would actually select the instruction. I think this is more logical. And then we could then do this stuff for selecting actual register, be part of the code gen as it should be, right? Does that make sense? I think it makes sense. I think it makes sense, yeah. Okay, let's try it out anyway. So, wait, immediate is fine, OPC is fine, because we start with C7, we assume the, we could start with C6 and just add 1. I guess, whatever. So we will do this. And then we have 8, 16, 32, 64. 64, and then anything else for now will be unreachable. Oh yes, Kimirata, the article about allocate. Correct? Is that the one you want to discuss later? Yeah, sure. We can. I can definitely do that. We can have a look. I think I even started reading some of it, but it's actually longer than I thought. So I was like, okay, I'm gonna take my time. Yeah, no props. Okay, so here we have for size 8. I think this is this case. But we also need to test if, or actually, and then immediate, and then if it's an error, and actually before we do this, what are the errors here? It's an overflow. Now, do we want to handle overflow as an emit result? I think we do. So we don't want to, we only want out of memory, I think, as the return. So I'm wondering here, because I've been kind of tweaking this stuff. I needed for the test. Actually, this is only for the test harness, to be honest. Maybe that's an overkill, but I needed emit result to be able to return an enum, a tagged union of okay or error, and then error is actually an error message that we create using the compiler's machinery that will be then flagged, that would then be returned to the developer. But I guess I need to think this through, because maybe this isn't technically needed. Right, so we want to catch anyway, and then we want to return an error like we did here, like this. And call this yeah, let's leave this at that for the moment. And this is going to be the immediate. Should probably call like size of or something, but okay, we'll do this later, I guess. Okay, and otherwise, if we have the immediate 8, oh, let me just 8-bit immediate, and the cast was successful. The opcode is -1, that's correct. Model MX is actually 0, which is fine here. Fine. We don't actually need the cast anymore. We just need that. Okay. Sweet. And then for 16, we also need this. Right, and then it's the same result. Fortunately, it's a lot of copy pasting here. But in this case, we don't actually need to. What is happening here? Why? Oh, because then have that one, and then we're gonna try actually encode it if I am 16. I wonder if it's actually gonna work. And then for 32 bits, do we want to leave it? Yeah, I think we could technically have it like this, because this is still going to be the same thing, and then we need to be able to cast that. Oh, this is I think IM is 32-bit max, right? Oh, it was somewhere there. What? Wait, where am I going? Just a sec. Yeah, we don't need the cast. Sweet. Okay, so this should be fine. -1, up. Okay, and then that is gone. And I think this looks better now. Let's see if this actually builds. And we have 2 tests. I'm actually gonna open that up here. So this is still this case, okay. Let's see what happens. Oh, nice, look. Okay, so this now works. Now we have to verify if this is actually correct. Because I believe this might not be. And this might not be correct. Let's see, C7. It is not. So interestingly, this doesn't work. So either we, or is it CH, not CX? Hi, Hikaru. How are you? Yeah, I'm good, thanks. How are you? I like Rust, but sometimes I just got mad because of the ideas of borrowing and ownership. Haven't we all? Making everything harder than it must be. So can you convince me to consider Zig? Pretty sure you have some good arguments about Zig and how it works because you're a core developer. Yeah, so sure, I can try. So what? Okay. Maybe before I go there, just to give you some context, what we're doing here, I'm currently refactoring middle level intermediate representation in Zig, and this is targeting the x86-64 code gen, that backend. basically trying to work out what the best way to lower basically lower abstract instructions into move. No, it is, but this is the wrong mnemonic outcross. This is actually mobabs. We actually have it as a separate one. Sorry, Hikaru, wait a minute. Give me a sec. I'll just. This would be like this. Like, I don't know. What is it? RCX, right? And then 1, 2, 3, 4, 5, 6, 7, 8. I think. Yeah, so we use the move abs mnemonic here for actual absolute push, and we actually use that stuff for in ELF. We are not allowed to use it on macOS anymore because everything has to be a position dependent executable. So that's a no-go. I mean, it doesn't make any sense anyway to address anything by a complete address on macOS anyway. Everything has to be a rip relative displacement. Anyhow, right, so Zig. Convince you to Zig. Yeah, so in Zig, we don't have the concept of borrowing and ownership per se. Like, we don't have a borrow checker. That's the first difference. Zig is more, it's like C on, it's not, well, not exactly C on steroids, but because it's got like many like very cool concepts, and it's actually way more powerful. We have very powerful comp time execution, meaning that actually operating on types is super easy. It's like duck typing. So this is really cool. It took me a while to actually get my head around this, and actually I used to code in Rust professionally for I think 2 straight years, and like a lot. I used to contribute to WASM ecosystem a lot, working with the Bytecode Alliance and stuff. This is where I actually discovered Zig, met Andrew online, and I started contributing some WASI into Zig, and I got hooked. And fast forward a year and a half, and here we are. But yeah, Rust has a very steep learning curve. Got him, yeah. Thanks, Andrea. Hey, wait, that makes me like a Pokemon. My daughter is not on that at that stage yet. By the way, anyway, so yeah, we don't have a borrow checker, and I used to write a lot of Rust, and I think it took me, almost a year and a half, maybe a year, to be comfortable enough with Rust to be able to actually think about a problem in such a way in my head that it fits the language. And then I discovered Zig, and what Andrew was saying, that this is all wrong, because why would you think about the problem in terms of the language, where this is just a tool. You should think about your problem and how you want to solve it, not trying to structure this around the language. And I think this in Rust, this is the case because of the borrow checker, right? Yeah, you're welcome, Brabengeir. Sure, I'll be definitely putting the recordings on the YouTube channel for the foreseeable future. Anyway, back to the thing. So in Rust, because of the borrow checker, I think you have to twist the problems in such a way as to please the borrow checker, because that's the requirement. This is what makes it safe. The static analysis, provable static analysis, I think it's called. So Zig is way more relaxed when it comes to this stuff. We do, however, have a lot of powerful runtime safety features, like traps and things like this, like overflows. All of this is actually caught at runtime in debug and release safe mode. So you can sleep. You should sleep fine knowing that actually it's we have a lot of avenues for safety. We have, like Andrew's likes to put it, we have different view of safety. I think we also one of the ideas that Andrew had, and I agree with this idea. We're not there yet, but it's having basically bits of code. Even think about this, like within a function, you can have a block that's you mark as release, and you actually compile this stuff in with full optimizations, not worrying about UB at all. And then there are bits that you're not exactly sure, so that last bit can be release safe or debug or something. So our aim will be to mix and match, and in this way you will get like a a cool balance. But I will, we won't add a borrow checker because that would make Zig rust, and that would be silly. Zig is, I think it's aiming to, being closer to the metal than Rust is. Working with the hardware should be, it's a pleasure basically in Zig. So a bit about this. Zig is a very simple language by design, so it's easy to pick it up. I'm sure that as you will be watching this stream, I'm sure you'll be convinced of this. There isn't, you won't find that many things that will be like, oh, surprising. After a while, it will be like, oh yeah, I know what to do. I know how to do it, and you will be able to focus on your problem straight away. So I hope this is a good pitch for you, and enjoy the show, I guess. Right. So back to the thing, as I was saying. So let me quickly recap what we're trying to do here. We're working on the code gen for x86-64. So this is basically taking the analyzed intermediate representation. Oh yeah, thanks Andrew. And yeah, Hikaru, check out the ziglang.org homepage. And sure, if you come back and ask follow-up questions, no problems. I'll be happy to answer them. So we have the x86-64 code gen. We have the middle. We have the air, so the analyzed intermediate representation. We want to lower it into middle intermediate representation and then to emit it into actual machine code. And we're trying to figure out. We're trying to basically fix some of my poorly written or thought out x86-64. Yeah, you're welcome, Hikaru. Code gen bit, because I have to admit I didn't actually understand it very well when I was writing this. So it was mainly test driven for me, but it turns out actually that wasn't the best idea because things got away. But I guess at the same time it's okay, right? We're working through it right now. So we're taking a different approach now. So we'll add like a very conservative constrained unit tests for a single MIR instruction into actual emit, and then we'll see whether it makes sense. Because I think that's crucial to get the mapping right. If we get the mapping right, then we can go back into the code gen and fix everything there, see if the test pass for stage 2. Anything that doesn't, we can then rework, see what the heck. And when that's done, we'll be, this will be the home run. We'll be on our way to actually adding a Zig test, pretty much. I mean, yeah, we can try that actually, even without the proper register allocator yet. Because I mean, we have something, but it's kind of greedy. And we, Joachim, our community member and great contributor, who's working on the ARM backends. We want to add the proper register, like I think linear scan register allocator, but that's gonna take some time. So in the meantime, definitely can try adding Zig test. So let's see. Hopefully this will generate some errors now. Or maybe one. Wait, let's see. Oh no, wait. CH is just a byte, is it? Oh crap. So wait, let me have a look. I'm getting confused with myself. What's the 6? Yeah, this CH. Oh shit. Okay. So. So the problem I am having right now is actually trying this. Okay, what is the 66? Oh, Jesus. Move instruction. That's for jumps, I think, is it? A SIMD. What? I want to. What? I definitely did not ask for a SIMD. Ah, this is great. And to think that I thought this is going to be a quick refactoring effort. Wait, where was the SIMD stuff? Oh, mandatory prefix. Okay. What? No. No, hell no. That's definitely not it. Oh, unless maybe this is one of those. Wait, that one is prefix to 0F, is it? Yes, 0F. Ah, good afternoon, Tiger Beetle. Is that all of you guys? Or is it Yoran or... Still 0F. Damn. Ah, there we go. Move double word or quad word. Fancy that? This is SMD. Huh. Okay, how can I specify that I don't want any SMD? Although, there should be 0F, and we don't have that. So maybe it isn't exactly. Maybe I'm actually wrong here. Wait. What about this? Aligned. Still 66 0F. Not exactly what we're seeing. Okay, Andrew. Have a good night. Bye-bye. I'm just one of the Beatles in the cluster. I love this. Hi, Joran. Yeah, it's great to have you here. Oh, by the way, I need to take a photo, Joran. All of the stickers from from the great swag that you sent me are actually on my laptop now, and they look slick. The Linux laptop, they really look nice. I need to take a photo. They really fit, like perfectly, I would say. Yeah. The sad thing is, I actually had I need to maybe print them myself or something. I had a collection of Zero and other Zig. Thanks. You follow. Okay. Thanks, Aaron. Yeah, I had a collection of stickers for Zig mascots and stuff, and I lost it. Oh, maybe Aaron will be nice enough to send you some. Look. Oh, look, if you have any leftovers for like Zig stickers, you could send me some too. Or maybe I'm just going to come over and get them from you, because I lost mine. I have no idea where they are. Oh, maybe it's move. No. Yes. Yeah, we already looked at it, didn't we? Aww. Yeah. I think I'm pretty sure I had mine. I'm pretty sure I took them from Handmade Seattle. And something tells me I gave them to my daughter, and that might have been a mistake. Because now I have no clue where they are, and it's a 3-year-old. So naturally there is such a mess everywhere that I have no idea where half of my things are. So they're good as gone, I guess. Or maybe in 20 years I'll find out. I'm like, look at this. Yep, definitely look lost in the ether. Ah, geez. Okay, so this is kind of annoying. I don't actually want. Wait, what? What? What if I did this? Wait. What was this move? So we're looking at that one. Oh, this is the immediate. Of course it is. Immediate wide, right. Maybe I had it wrong. Wait. But, okay, so no. This is definitely the mod RM stuff. What if I do... Okay, I think I know how to spoof it here. We can also do that. With BP... Actually, it can be 0, whatever. Ah, where is the thing? Oh my god, I lost it. Right, there we go. And then we can have that. What is this gonna yield? Is it not? Really? That's... It isn't. Interesting. Wonder why not. So we can't spoof it this way, really? Outcross, is that a question to me? Did you mean x86? What do you mean? Oh, here somewhere? Oh, you mean this bit? No, I mean x64. No, I mean x64. I just want to see if I can, because I think this should work. I think this could be a memory operand, and then we could have an immediate directly inserted into that, like we would actually push onto the stack. But maybe it's written a different way. I'm basically what I'm trying to do. I'm trying to get this, but somehow, I don't know why this online disassembler. We can try another one actually, before I start messing with things. This online disassembler is not producing that for me for some reason, and I have no idea why. Yes. Hi, JZ Cyan. Okay, what is this? No, we want... Wait. Oh my god, is it AMD 64 or something? There we go. Yes, base address, don't care. Endian, little syntax style, Intel of course. Suffix mode. Let's go with default. Okay. Oh no, are you kidding me? Can I write here? I can't. Okay. So so this isn't correct, but okay, so let's try. What about that one? OI. So that's B8 plus the register. We're trying what? I think AX is gonna be the easiest one because it's 0. So it's just gonna be B8. I lost it. There we go. So wait. This should be No. Surprised. Oh, wait. I think I made a mistake. No. Or maybe I did. Wait. Maybe it's not exactly that. So this is actually... Where am I? We want AX, and this is actually... So maybe we need some kind of a prefix. How can you work out if you have this? What's the difference between that one and that one? So I'm trying to think, how does the CPU know? Because presumably the ID of RAX, EAX, AX, and AL is the same. And that should be 0, right? Am I correct? I think it should be 0 for all. But then how does it know whether it's a word or a double word? Oh, okay. And how is that? Why do you need a 66 prefix? Is it actually written anywhere, like described? It's probably in the manual somewhere. Because that's exactly what I'm seeing, but I thought that was only for SIMD. And is... Wait. No, where is the M? Because I don't see anything here. And how do you... And it would be cool if you could explain, Tiberian, where you can find information about this stuff, like about prefixes that are needed, or is it like generic? Because I'm pretty sure this is going to bite me in the bum in the future. I am certain. And it would be cool if I could actually have some docs for this somewhere so that I know what to expect. But anyway, let's get it for a spin. So basically what you're saying is this would be 66. Okay. So if you try, okay, so you get a C7 opcode and the prefix, right? And that's exactly what we wanted. Okay, so the 66 prefix is needed. Gotcha, okay. And is it going to be applicable to every, like, other similar opcodes, or is it only move specific? I wonder. I mean, I didn't find it, that's why I don't really like AMD manual, because I don't know, I find navigating through it pretty difficult. So here we would need, I think it's 2 byte. Encoder. Opcode 2 byte and prefix, and yeah. So you're saying this should be the case, right? And let's give it a spin. So this should actually yield an error. Because, wait, this is for 32-bit. Okay, this is it. So we should have that one. This should be CX And then that one. This is for 1 byte. High? No, low. Low, right. Okay, definitely not just from. Okay, cool. Thank you. I need to find some source for this. This is super frustrating that it's not actually, like, there's even a hint under the move instruction. Maybe they just assume that you read all the preceding 2,500 pages, which I haven't, so not yet, I guess, at least. Thank you, Tiberian, thank you, Aukras. I'll definitely keep that in mind, and then I'll definitely have a look. This is interesting, and this is actually, obviously this isn't optimized. We could probably shorten this using the OI instead of the MI here, but it will do for now. At least it's going to be correct, I hope. So for that one, I think it's C6. I think it should be something like this. C6, C1. Is it? Yes. Oh, that should be CO. Nice. Thank you. Thanks, guys. I very much appreciate this, because this would probably take me the entire day to figure out. I mean, I know that I saw the 66 byte in the assembler and disassembler output, but I'd rather trust you guys than trust a tool that I don't even know if it's maintained or something. So. Hey, perfect. Okay, that's awesome. So now let's test some error conditions here. We should also test the React stuff, but we can do that later, I guess. Single fail. Right. So a failure condition is going to be, what is it going to be? The opposite way, right? So for example, ECX. No, that's fine. CX, that should be a failure, I think. And it should be size mismatch. The error message will definitely need some improvement here. Oh, and I'm actually going to do that stuff. Size mismatch, not actually printing a decimal, but actually in hex. Yeah, the funny thing is, since I started working on the linker and code generator and other bits in the backend, dealing with hex is so much more natural now than even printing decimals is just weird. I still operate in decimal though in real life, like normal life, by the way. I haven't fallen yet. I'm not talking in hex. But doing all this stuff and dealing with alignment in the linker, so much easier in hex, like so much easier. Nice look, yeah. Hey, sweet. Okay, so this is fine, and then the same single fail. I don't think we have a different fail there, but for that one, okay, cool. And then the same fail should be reported for the case where this is CL, and then even that should be the case. Oh, we should see. On error. Yeah, I guess for WASM, I actually didn't realize that there is so much lib one, like the, what's it called, lib 128. What does it stand for? Never remember. Oh, little endian base 128 encoding. I had no idea there's so much, like the entire WASM file format is based on lib 128. That's I mean, that's clever and kind of sad at the same time. I think for any incremental updates, this makes it kind of difficult, right? I mean, look, you can be, yeah, pretty okay, but it does make it difficult for in-place binary patching, right? Because you cannot just know where to put it unless you you make everything max. What's the max for lib 128 when it comes to encoding? How many bytes? Is it 7, 8? Can't remember. Oh, 5, right, 5, yes. So everything is a 5 byte instead of being like 1 or 2 or whatever the compressed one is, yeah. Oh, 10 for 64-bit, okay. Gotcha, okay. Yeah, so the lib 128, this is an interesting thing, is also used to calculate the so-called export try in the Mako file format, and this is basically for the loader to know what symbols are exported in a very compressed way. I mean, it's encoded as a try. It's then serialized using lib128, and to serialize this try, you need to actually do a couple of recursive passes, because you need to compress, compress, and compress until all the everything is properly encoded in lib128. And because of this export, that means for in-place binary patching that you have to do it every single time. Unless you make everything 10 bytes, but then this kind of explodes. Or maybe it's worth looking at. I don't know. I mean, at the moment in Mako, we actually regenerate the entire link edit segment at every change. And this is mainly because of the fact that Apple tools have, so basically Apple they have this like unwritten specification for what constitutes a well-formed Mako binary, and this is great. I mean, that's fine. I totally see why. I totally appreciate that. The problem is that it's nowhere written. The only way to actually get a hold of this stuff is to dissect and analyze some of their tools like CodeSign alloc or CodeSign. That's where this is enforced. And for I don't know if you guys know this, but for the new M1 family of socks and basically the ARM64 macOS, if you or even distributing anything on Xcode, you need the binary to be well formed, because you need to be able to code sign it like properly, like fully. And basically I decided like, okay, if this is the case, I'm not even gonna do any like fancy business with trying to push the link edit sections, like the load commands, like for example the DYLD info or string table around. I could, and I did, and it did work, but then the code sign doesn't work. And I know it's going to be slower, but I guess we don't have enough of measurement data to say how much slower it's going to be. Oh, nice. Yeah, so yeah, you definitely should have a chat with Frank. Look, for the WASM code signing proposal. Oh, of course, because so the WASM world is also going to see some code signing stuff. Excellent. I don't know. I mean, so I'm not sure we're going to have time today because I would need to switch the machines. But anyway, one of these days we can actually discuss the code signing stuff on macOS. And I got bitten by it. So one of our community contributors, Master XQ, who's doing some amazing work on like the ecosystem, the different libraries and stuff that he's providing. He's been working on a thing called TinyVG. Let me show you. I think it was tech. Whoops. Oh my god, no, tech. Maybe it's not online yet. Yeah, maybe he hasn't released it yet. Anyway, oh, tinyvg.tech. Okay, I don't think tinyvg.tech. Oh, there we go. Perfect. Right, tiny vector graphics. So why another format? This is SVG is a very complex format, and this is basically an alternative, and it's great. You know, all the features are fantastic, but the thing that basically actually surprised me, and not about the project itself. XQ asked me to test some stuff for macOS, and specifically the ARM64, and he sent me this stuff with an example C code. I built it. Some wrinkles that were already I have a proposal for fix, but that's unrelated. I built the program, and then, you know, lo and behold, I try and run it, and then DYLD is complaining that the shared library that I'm linking against, that's basically part of the distribution, has been ad hoc code signed, not on this machine, and you downloaded that stuff. So I'm sorry, but I'm not gonna load it because of the security stuff. I was like, what? So, and in this case, this is horrible. I think this is what Homebrew had a problem with when M1 was out, and yeah, I need to fix this. This is horrible experience. Like, I have to go open Finder, right click on the dilib, you know, then click open. Opening a dilib, I was like, what the fuck? Open the dilib. This automatically adds an exception in the OS, and then you can rebuild your binary, rerun it, and DYLD will load the stuff. Yeah, but for the apps, if you right click on the app, it's okay, right? I mean, this is the app, so you are expected to, like, not a power user is expected to basically double click on it and run it. But this is a dilib. Like, why the hell would you actually right click on a dilib and open it? There is another way of actually adding an exception via, I think, settings, but this is still ridiculous. I was like, I don't want to do this. Right? It's a bloody dilib. Like, Jesus, like, why would you expect any security exceptions on a dilib? Like, I know it's a executable piece of code as well, but come on. So yeah, this is why I really, really appreciate Linux. You know, there are different problems, sure, but none of this, like, over-the-top security stuff, in my opinion. It's just over the top. So, yeah, fun times. I definitely need to look into it. I'm not sure. I need to see what Homebrew, if anybody has any ideas or any pointers, that would be very much appreciated. What Homebrew did with their, because they had the same problem, the code signing. And I think the recipes are fetched, right? They're not built locally. So I would expect they have somehow handled that stuff. I'm kind of worried that this requires a code signing tool fork in a way. And what I mean by a fork, like, in order to build this properly, you will need to be able, like, you need a Mac. We don't want a Mac. We want to be the user to be able to actually code sign properly anywhere. And I think this will mean that we'll need to figure this out, how to do this. So that's another side project. That's probably going to be much, much more complicated than I initially assumed, because you know, going through Apple source code and for anything that's actually out there, or figuring out how it works, it's always fun. Anyway, back to the thing. Okay, so we got that tested, which is great. The size mismatch here is easy, that's done. And then, okay, 0B01. Right. So this is fine. We select. So this case, actually, what do we have here? We have two things. And maybe we can focus on that one first. We have, so this is the register and memory operand. So actually we are, either the source is a memory operand. Oh no, it's always a memory operand. But it can be just an immediate. Is that the one? Is that the one? Yes. So this is the immediate with respect to the segment start, I think. It's that one. No, that one. think it's A1. Yes. And so this one, oh, by the way, this one is only useful on nowadays on Linux. Is it that one though? Or maybe it's that one. Wait, let me have a look. I can't remember what I did there. It's 0. It's okay. This is Oh no, it's not that one. It's actually 8A. So, okay, it's that one, right? Okay. Yeah, some of the stuff is actually, I think, useful only on non-Mac OS hosts. Nowadays with Mac OS, actually, although Intel is fine. As far as I remember, Intel, like on Intel Mac, even though the new kernel is out, I don't think they have so many restrictions on the Intel Macs. On Intel Mac, I think you're still allowed to do a static, to a non-pi binary. I'm pretty sure you can do that. Or maybe you can't. I can't remember if it can be position independent. If it may be not position independent, I meant to say. Can't remember. But given that Apple is actually scrapping Intel entirely, I don't think there is any point in actually trying to investigate. On ARM, everything has to be a Pi, so why bother, I guess. Okay, so that bit here. I guess in this case, the displacement has to be 32. There is no other way, I think. There is this 8. So let's see. So this is mod RM with scale index base displacement. And I wonder if we can actually do displacement of 8. Well, let's have a look. So that would be just a sec. Okay, so this is move like this. Let's have a look. Let's go with RCX stop. Okay. And what if we do but the displacement is still sorry, this right? Yeah, it's still 32 bits. Okay. Okay. So, and what about there we go, with fancy prefix. I had no idea I need this. So wait, what if I have oh my god. And now there is none. Wait, let's go back for a minute. So that was CL, and this one actually gonna generate, not that one, okay. So 66, 66, C7, C1. And then okay, this is actually, okay. What about this case? No. Is it W? Yes. Word, and then... Okay, into manual says, let's see. Okay, thank you, Akras. Okay, 32-bit mode, the assembler may insert a 16-bit operand size prefix. Okay, so this is everywhere. Okay, good. Oh, I got scared. Okay, so yeah, this is insane. I mean, so surprising, to be honest. I mean, yeah. I want to say that actually reading through ARM64 manual is just slightly easier, but then again, I think I already spent more time on x86-64 than I did on ARM64, so I'm not gonna say anything prematurely because I might be wrong. Maybe there's also some weird stuff. Insane, right? Okay, so here, whoops, right? So what we want here is actually that, and then is it direct sequencing? I think the DS stands for. Still 66. Okay. Oh, nice. Oh, was it? Wait, Control Shift. Oh, yes, perfect. Thank you so much, Tiberian Outcrust. That's very, very, very helpful. Thank you. Operand size override prefix. Oh my god, I love the naming convention. For 64-bit default operand is 32-bit. Yeah. So probably it needs another prefix to make it right. Yeah, that's why I assume that there has to be a way to signal that what to expect, right? Because the CPU will not know if they see the same prefix, like prefix. Forget about the 66. If it's the same opcode, the same register ID, and then the CPU would naturally expect, as you said, Alcras, 32-bit operand, but what it was 16 bits, then you have to be able to tell it that it's something else. Okay. Wow, okay. You can actually switch. How do you switch? Allows program to switch between 16. Okay. Right, and the prefix is used. Okay, I am assuming. Okay, this is excellent. I am definitely going to download this. Move this, and then so that we don't forget. From the default of 32, from the default 30 to 16 bits. Okay, thank you. This is very, very helpful. Thank you so much, guys. I guarantee this is gonna bite me in the ass in the future. Positive that's gonna happen. Okay, so I think this is fine then. The only thing, wait, we have this. This is fine. So I think even though it's always gonna be the same, right? It's 44. That's the rex. Okay, and yeah, sweet. Okay. Can add some testing. destination register, and then we have immediate. So memory operand, cool. Oh yeah, I was meant to ask you, Hikaru, was it? I think. Yeah, Hikaru, how do you find Zig so far? You haven't seen much, but I bet that the dot prefix is kind of confusing everywhere. That's definitely what confused me in the beginning. Okay, we don't need register here. Let's start off with RCX. That's fine. We have the immediate, and then we should expect $8B0C20. Okay, I think this looks fine because we have what? We have Rex, opcode. This is mod.rm with SIB displacement as the SIB byte, and then we have the immediate. Okay, I think that looks fine. That's what is this? RCX immediate 10. And then to repeat this for a similar case, but this time let's go for that. That will change the Rex to, what is it? For C, right? Yeah. Oh, by the way, guys, if you're gonna be interested, one of the topics I definitely want to do, and this will probably apply. I'll probably do it for Linux, for ELF first. Obviously working on the linker, but looking at optimizations in the linker as well. So by optimizations, I mean link time constant optimizations, like got in direction relaxation and stuff. Actually, ELF is super clear about this. They give you even, ELF is passing you separate type for a relocation saying like this can be relaxed, which is awesome. On macOS, that's not the case. But this is something I want to look at, and some of the stuff actually may and probably will require some rewrites of the actual assembly. So sometimes with ARM, for example, if you can elide some of the like large jumps, oh, okay, cool. Take it easy. Look, if you can elide some of the reads from like far reads, for example, because on ARM64 you would normally like here you do use a move or a load effective address, LEA. On ARM64, as far as I remember, you would use a pair of instructions like adder p, which is the address of a page, and then you would have either add or LDR to actually to narrow down where in that page the address of interest is, to then do something with it, like dereference it or load it or whatever. So the linker sometimes is actually if the distance is not too big and it's actually within the scope of a single instruction, it will elide the first one. It will just substitute a nop, and then for the second one, it will just rewrite that one to a different one, like ADR, I think, or something similar, or LDR with a label instead of a register, things like this. This can go wrong in so many ways. It's so funny. So yeah, definitely want to do that again, because I did some of the stuff in the past, but I had to go back because this actually takes time. Just like another optimization pass in the linker. And I think sometimes, especially for in-place binary patching, it might not make much sense in the debug build, but for release, this is definitely on the table, and it's a lot of fun. I highly recommend this stuff. This is it's good stuff. Right, R11D. I think this is the same one as that one. Let's yank that. I think. Oh, just the size is different. So that's gonna be 44, I think. And then move R11 D. And out of curiosity, has anybody ever played with ARM64 ISA? Or rather, do you have a comparison, like what you prefer, x86 versus ARM66? I'm kind of curious to know what you guys think. What is this for that one? Right, the 66, and then okay. So you all needed Outcross. You did mainly x86 64. Is that correct? Okay. Oh yeah, I did a bit as well, man. I mean, I'm learning as we go along, and you guys already taught me a lot. So I'm very thankful for this. This is like invaluable knowledge. And as I said, it would actually take me a long time to hunt down. So thank you for that. Okay, this is 8A. 8A. I think it was the same one. Okay, cool. And that should already pass. Let's see. Oh, I might have forgotten about the prefix. I think I did. Ooh, that is some difference. Interesting. 41. Okay. Then if is 16, we are going to do upward 2 byte, and that's 66 prefix plus OPC, else and okay, did I mess something? Is that not? Wait, what? Oh, that's expected. Okay, good. 4C, right. 49. And it's 1C, not... Okay, interesting. Let's have a look again. Okay, so I definitely did not copy the right thing properly. But it's still giving us what, 49. Okay, let's have a look again. 49. Uh-oh. I think I know what the problem is. I think this is it. I need to rerun it again. I think that was it. And then, did I copy that stuff over properly? No, I did not. Again, this will be it's 1C, not 0C. Okay, I think this is the only difference. And then that one is fine now. Okay, and that one should also work. How to reach unreachable code? Ah, yeah, we whoops. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, jeez. Yeah, so we actually when you edit the encoder here, you specify the worst case, or at least I use it this way, that you specify the worst case for a combination of things. I guess from coding perspective, it's a bit clearer. But if we want it to be super optimal, I wonder if it would make sense to just have it per case. But then maybe the cost is not that big, so maybe it should be fine. Wow, this is amazing. This is excellent. Yeah, I'm so glad actually we ended up doing the test. This is very reassuring now. I don't know if you guys if you ever had this feeling, like when you work on something new and then you do something and it's kind of like taped together, or at least it feels this way when you actually don't have a proper idea. Yeah, that's why I thought, okay, so the first byte, I think we need to add that one here. How to do this? Let's clean. Yeah, so I think this one can stay as it was, and then if ops reg 1 yeah, we're gonna add here prefix. I wonder if this is actually gonna work with the encoder. And I think we need to fix that in the previous case too. Maybe add some tests for this. Here. In fact, this is kind of silly. We could probably do that, and then if if the register size is actually 8, we can have 6, and then if it isn't, then we're gonna have 7. That's fine. And then here, before we do regs, if ops reg 1 size is 16, we do nice. We do encoder opcode 1 byte, and this is the prefix. What is the thing here? We do that. Here, this is it has to be +1 because I didn't take that into account before because of this prefix plus the arrays. I think it's going to be 8 maximum. Then we have just the op. Oops. We have mother mx. Okay, cool. And then we're gonna do the fancy schmancy here. And have that's the actual. Let's call it or typed, scaled. immediate will be here. We will not need... Oh wait, no, that's fine. We don't need that. We just don't need this. I think. Okay, yeah, I think that makes sense. Okay, and let's try that here. So that was the move. The worst case, what is the worst case? I think it's that one. Let's copy that stuff over. That's R11 white. Not here. Not very helpful because it's not this opcode. Still only 6. How come I had 8? Or 7, in fact. Oh, it was for 7. It's actually 7. Okay. Here, we were fine here. No need to pre-allocate too much. It's because of that one. 1, 2, 3, 4, 5, 6, 7. Oh no, it's gonna be 8. No, it's gonna be fine. Okay. Because this is already with Rex white, and then okay, right. It should be fine. Just the I think the encoding for the R11 wide is gonna be wrong there, so we'll fix it here. I'm pretty sure this C7 is fine. 44 probably is fine. C1 is probably wrong, or maybe it's okay actually. I can't remember if you actually add any bits from the register here. Oh, it's 41, it's 44, is it? Okay. Is it indeed? Let's see. I think I copied the wrong thing. Yes. Scary moment going like, huh? R9, what the hell is R9 doing there? Oh, right, okay, so this is what I was saying. It's not that one, and they say, given... Oh, it's... encodings. Yeah, correct. Nice. Awesome. No, let's copy it from here. Ah, shit. Ah, this is getting better. Cool. Can you imagine how much of this was wrong? I wonder what kind of a miracle that is that we had the existing stage 2 test passing on x86-64. Yeah, I know. It worked exactly. Oh, this is what a disaster. I'm serious. Like, oh, I feel so ashamed. This is so bad. I guess you could say that the task just out like overwhelmed me. It was too much. I did try and squeeze it before Handmade Seattle conference that happened in November. So I was trying to get that done before, because if I didn't, then I would lose a week, maybe more. Probably 2 weeks if the jet lag counted. Like actually I take into account, and then I would lose 2 weeks. I would forget what I did, and I would have to redo it, or worse, things would be added in the meantime. Done. So I pushed for it, but I don't think I'm not sure if it was such a great idea, to be honest. Well, at least I guess the machinery is there, right? All the required code around it is there. So I guess at least that's some consolation. Oh dear, this is gonna be so much fun now, fixing the codegen. Oh. And we have some, I'm actually going to show you guys, we have some crazy examples. I'm sure Luke has seen them. Let me show you some of this stuff on the spilling. Oh, this is amazing. Look at this. And honestly here, when things go wrong, this is like, basically, I even have some of the stuff when I was working. I think, I don't know if you can see this. I was going instruction by instruction. And then, wait, this way. And working out line by line what the hell is going on. And it's so easy to make a mistake on paper too. Yeah, I have actually, this is my second or third notebook. Look, I have a couple more, like for linker design. I had like 2 A4 pages with arrows going from one place to the other, shit scribbled everywhere, trying to work out what the fuck, where the address is changing, why are reading stuff from here, why is it there being like, intercept there and there and there, and all this crap. I'm like, damn. And then after, working it out a couple of times, writing the linker, I'm like, oh yeah, now that makes sense. It took a while to get there. Oh dear. Okay, right, back to the thing here. So this is the displacement. I think for the displacement, we can either have... Yeah, I know, right? There are some good tools for WASM, yeah. I guess people learned over the years that, the mistakes that were made before. Or maybe because it's a consortium of people working on it. Maybe that's why it's different. It's not just one, although nowadays it is mostly one company driving it, maybe 2. I don't know. Yeah, I like WASM. WASM is cool. Right, anyway, back to the thing. I think we can have either displacement 8-bit or 32-bit displacement here. Let me have a look again. Let's consult the notes. What did I have written here? Because I think mod RM byte can have mod RM byte. I think can have 4 modes of operation, because I think we have 2 bits to select what we want to do next. You guys can prove me wrong or correct me if I'm wrong here. But I think that was the case. Yes, I think we had the actual mode we want to use is either for 00, that's register indirect addressing, or SIB with no displacement, or displacement only addressing mode. Oh fuck, when RM is 101, okay. So wait, I think this is this one, is it? No. Oh, and then we have 0B01, it's 1 byte sign displacement follows addressing mode bytes. 10 is 4 byte displacement. Sign displacement follows addressing mode bytes. And I think these are the 2 we are interested in. Let's see. Was that the case? Yes. Okay, 01. And it's 10. Okay, nice. Ah, sweet. Sweet Jesus, if you have... Oh, I love Intel. Look, and then, of course, because then to extend this stuff instead of actually yeah, okay, so to extend this stuff, they basically said yeah, we can repurpose rm, make it what is it, 0 1, that's 4, make it number 4, and then if it's a 4, then we actually use only the middle 3 bits for register or operand, and then we add the SIB displacement byte, sorry, where you're gonna stick the second operand. That's genius. And then I'm reading this going like, what in the hell? Okay, so the same story here. We want to react to sizes, so we want the size to be telling us exactly what we're going to do. Oh, okay, the opcode is already handled there. Oh, wait, okay, okay, because we did that already, and this is with the correct, okay, correct, cool. Confusing. So we have the opcode done, and then we definitely need that stuff too. So this is for the magical prefix for non-default size. Although, wait, do we need that here? Maybe we don't need that here. Could it be that actually it's only needed for like operands with different sizing? And I think here we should be fine, right? This should be okay. So if I do what was it, CX, and then I will make a displacement with respect to something like this. What is going to happen now? Oh. What did I mess up here? This should be, should it not be fine? Or is the displacement wrong? So that one is 88 or 89, I think, is it? No, 8. Okay, 8, RM. It's actually RM. Is this invalid here, by the way? This should be the opposite way, shouldn't it? I think this should be MR. No, wait. No, this is registered in memory. Okay. Oh, because we moved to. Okay, right. Oh, jeez. Right. Yes. So. Right. And then move to R60. Okay. So why the heck do you not like this? What if I do this? Okay, let's start with 64 bits. Okay. And this is gonna be fine? This is gonna be fine. Okay. Can this register never be something smaller? Okay, it can't be smaller. Okay, so this is the word pointer. Okay. And that is gonna oh, so I can't do that. So wait, is the second register always has to be at least 32 bits? Let's see, maybe Intel will have something to say about this. Oh, opcode map is... Oh no, I won't be able to work this out. Right. That's the machine instruction format. You know, I think AMD actually wrote this stuff in LaTeX. This looks so much like Word, doesn't it? I'm digressing, but it definitely does. This is like I think this is the default for headings in Word. So what is this? For non-64-bit modes, move data. Yeah. So yeah, I'm not even going there, look, yet. I'm just trying to do the basics. And I think, you know, progressively we'll be adding more stuff. Because otherwise I'm just gonna go mad. Wait, but this is, I just want, oh, instruction reference, whoa. Actually, I like this organization more than AMD 64, to be honest. It's easier for me to find stuff rather than this. Oh, and this is like a tiny volume. I think this is just one volume. Maybe that's why. And this looks exactly the same. Oh yeah, this is like this website. Okay, that's not gonna be very useful. 3751. Wait, can I navigate there fast? Okay, let's have. Wait, is that where is this? Should be in chapter 3, right? How do I get there? Oh crap! Can I just until volume 1? Okay. Do you have a link, perhaps? Maybe I'll find this way. Oh my god, I have a local copy. I hope it's not printed. If it's printed, then you know, kudos to you. Yeah, save it for later. Okay. Ah, nice. Sweet, okay. Oh wow, really? It was possible to order from Intel. Wow. Nice. Okay, so wait, right, yes, and 60, it must be 64-bit general purpose register. How come it works with EBP though? Because maybe it's just falling into, you know, because you can actually do, you could do this, right? But maybe there's some, maybe it's the same encoding, yeah. Maybe there's, wait, let's have a look. So it's 67, 66, 8B4D10. So it's 8B4D10. Something changed, wait. Oh, there is like some 67 prefix added. Maybe this is, could it be that this is the non-default sizing again? Or like non-default, like basically switching to 32-bit mode? I think that might be it, right? Because this is, you know, it's a prefix thing. And I guess it would make sense. It would be similar to what we saw with, yeah, I'll need to do the same thing. I need to read through all this stuff again. Okay, the displacement can be 16 bits, but that will that have any effect on? on the instruction? I don't think so, right? So if, and this should actually work on, right, and then we're actually gonna only read byte, right? We'll only we'll read from this location a byte and then push it into move it into CL. Okay. Right, this is cool. I think it's, oh, but this is 67 again. Oh, because it's EBP. Right, so I think for now, it's okay to assume that it's going to be RBP always. You know what? Maybe that was a different instruction altogether or something. Because there was like 66 and 67. Anyway, yeah, I think it's going to be fine to basically always assert, but the register, the base register, I guess this called, I think this is called base register, is it? Or is it called, what do we call this? It's base, right? It's not index. Index is the one that's in SIB. Correct? Am I correct? I think so. I think it was SIB. I think this is the base. So base, okay, so the base, I think we'll be fine here, forcing it to be 64 bits. Right, yes, exactly, yeah. Scale index base, yeah. So I guess in this case, this is treated as a base register, and it's, okay, so yeah, let's force it to 64 bits. I'm just trying to think, because I still think that it should be the code gen, not actually this bit of emitting, like converting MIR to actual coding. I think this one should assert or throw an error, whatever, right? It should assert or error out if there is a size mismatch. We should definitely not have this black magic stuff that I added before. I think this is the wrong place. Because this way, if we have it in a declarative way like that, then I think it should be easier to track any sort of problems down the line. So, okay, so basically, even before we get in, let's do ops reg and 64. We'll immediately return an error here. Yeah, it's either going to be an error or an assert. What do you guys think? Should that be an error or an assert? The thing with error messages is that they are the errors that we will report to the user. Now, obviously for the codegen stuff, this should never be the case because the codegen should know better. So basically, if there is an error like this, then it's fatal and it's a bug in the compiler. So an assert would do, right? The other thing though is inline assembly. Because there we don't have that, you know, we can allow the user to do whatever they want, and if they make a mistake, we should flag that up. But then the question is, should it be flagged? Should we flag it up here? Or maybe it should be a level above. So basically in the codegen, which is actually dealing with inline assembly. Because if we don't have to throw errors here, then that would mean we can actually go back on some of the changes I made in the way I organize this code base now. I basically simplify it. That we don't have to have a separate allocator and source location, which is actually, like, I just mock it to be some empty stuff that is irrelevant, and it could just be an assert. Do we even have expect panic or something? Or we could just throw an error, like not emit fail, but size mismatch. But there will be no note. I don't know. I'll think about this. This is difficult. So this should be, the size should be 64. Okay, let's leave it at that for now. And then we have what? Which one is the B in the mother? So R is the first one, which is fine, and then the second one goes in the B. Okay, indirect displacement 8. Okay, cool. Okie doke. It's extended, it's fine. And then we need to do on the sizing again. Yes. So here. Wait. How did that work here? This is relevant, right? This is. Okay, right. So this is not dependent on the register size. Actually, this can be either. Okay, that's fine then. I think this is fine. I think this is fine. So this one, and then we have okay, RCX RBP, fine, like this. So this should be I think this actually worked. Should play that one. Perfect. And then RCX RBP. So the same thing should actually I think that should be pretty straightforward. Oh no, this is gonna change the zip byte. I can't flip the bits in my head. It's 48 in 8D. For 8B, 8D, right, and then correct, and then we can also do some let's copy that over, for extended, just to be sure we covered everything. We could actually do what, for a byte, why not? And we could do the same thing for, let's say, word. Why the hell not? Okay. Well, so then this is R11. Right. R11, and then it goes here. Okay, 44. And same thing forward. Oh, look. So wait, did I miss that here? It's there. Interesting. So we still need the thing. Okay. It's 3, 6, 8. And this one is R11B and then R11W. Hey Loris, how's it going? Wait a second, okay. I'm waiting a second. Yes, I am using strings now. I listen to you. Why? If you don't like them now? Do you want me to switch? Please do whatever. Okay, so I'm gonna switch then. It's a joke, by the way. I'm fine with the strings. They actually look nicer, and it's actually easier to copy it over, to be honest, because I just go here and just copy that string literal and just put it in, and that's it. So I don't have to fluff about with actually getting the array right. So so this is pretty good. Right, where were we? This is 1, 0, so no, we're not there yet. It's that one here. So if it's actually 16, we want to do the prefix bit 66, and then otherwise that is fine. And then we have opcode 1 by blah blah blah, and then this is actually 8. Let's have a look. Uh-oh. Something is wrong. Oh. What? Array size mismatch. Wait, what? Where? Okay, why did it not print anything though? Interesting. Okay, Akros, thank you. So that's chapter 361. Okay, cool. Thanks so much. Yeah, I'm gonna have a look. Okay, nice. There we go. Okay, so this operand size prefix is 66, and that's okay. This is the address size prefix. Cool. Thank you so much. That's gonna be very helpful. I'm definitely gonna have a look, and then maybe augment the stuff with more things. Now the question is, why the hell does it fail? What did I go? Where did I go wrong? Oh, I bet you this is is that the, did I trigger? Oh my god, why did this trigger? Did I return an error somewhere? Am I testing the wrong register? I bet I am. I bet I am testing register 1 and I should be testing register 2 for 64 bits. And 32 bits, but I'm gonna add that later. Where are we? Too far. Not that displacement. There we go. Yes. Lol. Let me add a note. Oh, handle. And let me copy the yeah, that's Intel Manual Volume 1, Chapter 3.6, 361. Sweet. Thank you, Akras. That's very, 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 very helpful. We are doing great, I think. It's true that it's taking actually a bit longer than I expected. In the sense that I wanted it done, but before. But this is really good stuff. This is I think it was needed, honestly do. I have a feeling that after this, everything is just gonna be so easy. Yeah. Have you seen this, Loris? Look, I added like a very, very, very small, like kind of like a test. Was it expect equal strings, like a helper function, but just basically to this stuff. But showing me, where the encoding goes off. Okay, so this is R11B. I think, cook it up. Why did I copy all this stuff out? What did I do? R11B. Oh, I probably didn't change that stuff. Yeah. Yeah, so it's now easier, Loris, with this. Just, copy that stuff over, go here, and then copy that in, and that's it. So that was actually a very good shout with the string tweak. So thank you. Oh, by the way, how is my voice today? Is it synchronized properly with the video? Because we had some desynchronized, like basically it was out of sync, I think, yesterday. I didn't touch any config. Okay, cool. I didn't touch anything, but just wanted to make sure. What do you mean chat something is helpful because you can focus on things other than the main thing you're doing? Okay. Such as? Can you share them? Oh, by the way, look. Hey. Definitely going to commit that. Yes. Oh, by the way, is AOC now done? I've actually never done it, by the way, guys. I never did any advent of code. I don't know why. I did in the past. I did some things like exorcism, mainly in Haskell, by the way. I used to code in Haskell. Oh, it's until Christmas, right? Okay, Advent, obviously. Yeah, it's until the 25th. Okay, cool. Pardon me. Yeah, I don't know. I should probably do it, but oh no, I don't want a torch. Or maybe you can. I don't know. We'll see. I'm not as clever as you guys. It's probably gonna take me a long time to actually figure out the solutions. I guess you know what you did and backseat programming. Oh, maybe next year we could do like a double streaming thing. 2 people actually streaming the thing. That could work, right? Okay, what are we doing here? Okay, let's start with R11. That's fine. And then pflags 10. Yeah, makes sense. Well, today, thanks to Aukras and Tiberian, I think, I got some excellent advice actually on the ISA. This was amazing. I'm actually not stuck. And otherwise, I would be. So. Yeah, same here. I also appreciate suggestions. Like, as I said, some are excellent. Okay, so moving into a memory operand. So in this case, we already know that this is just reversed. So we know, thanks to Aukras here, that where am I? Okay, so for that case, in both cases, we actually have that assertion here. Yeah, I think I'm just gonna make it an error rather than having an error message with like a note or something. I think this can be actually done further up. Or can it? Yeah, oh, and this is actually wrong as well. I need to figure out this error message stuff. I think this might be an overkill for this layer. I think this should be the layer above should be reporting, should be taking care of the sizes, and then if there is a mismatch and it didn't catch it, then that's like a fatal error. I don't know. Damn. Okay, let's do this one, and then Retta wanted to go over the article about allocate, so we can go over this. Or maybe Loris, you have an idea. Or maybe we can take a break now. Let's have a quick look. Where was this? I don't have it here. Maybe higher up in the thread. Where was this link? Ah, here we go. Damn, I love Borg. It's so cool. Right, so did you can I go to like, can I immediately scroll to the beginning? No. Poor links. Oh my god, I'm so gonna do that. Wait. I'm sorry, Lars, I didn't know. Oh, by the way, we need to create we need to create. Once you make the first release, we should definitely create like a Nix package for it, because then I'll be able to just have it. Although I think I'll need to manage somehow, because I don't think it's gonna make it to stable until the next release. But still, it's gonna be so much easier to get it installed. Yeah, good luck finding N button on my Moonlander. I have no idea what that is. But anyway, Bork links. Whoa, look at that, guys. This is so cool. Did you see this? Oh, nice. I'm very impressed with Bork, Loris. It's amazing. Yeah, you should definitely get a split keyboard, and I'm pretty sure. So I like my Moonlander. I think Loris didn't, because it's was it too big for you? But I have to admit, I'm actually not using a lot of features that it offers. Like, I don't even use the overlay layer a lot. I find it quite complicated to use, so I just use like a standard keyboard with some remappings done, because some of the keys were just in a ridiculous place. Ah, right, corn with chalks, okay. Lotus, what did you have for your keyboard? So, version 0.9. Oh, by the way, Lotus, did you read this article? I guess you must have, right? Because Retta had questions. Let me find that. There's probably a way to find this. Bork something. Wait, maybe there's an option. Yeah, okay. Oh, like in one case, the vtable is separated from the object, whereas the other one includes it. Okay, so this is about the vtable. Oh, this is to approach polymorphism. Yeah, I think that's right. So wait, how do we have it? Trying to remember how we do it for example, linkers. Let's actually have a look. I even do that in the LE, I think. Is Retta still? Retta, are you still there? Okay, cool. So I think I do something similar for the linkers, and I think this is exactly what's done for the linkers in our source code, I think, in Zig. So in this case, LD is kind of polymorphic in the sense that we basically treat it as a generic pointer, like a dynamic cast, I think, or reinterpret cast. Can't remember which one. I think it was dynamic cast in C++. And depending on what the tag is, that's basically attached to the child. Where is that child? No. Mako, for example. Beats me if I find the tag. Oh no, it's actually part. Okay, so the tag is part of the base structure here. And then this one is set by, so we create the child, we set the tag, so that then, and this is a common field to every child, and then when we create, for example, Mako, create empty, where is it? We basically created on a heap. We return a pointer to it, like an open path. But then we actually get the base field, and the base field is ZLD. So we actually create ZLD. We hold it. We store it within Mako. We store ZLD within ELF too, and we do the same thing for cough. If I can go back here, you'll see the same thing everywhere. Right? It's the same structure. So basically these two things, the public const tag and base ZLD, they're shared by every child. No, you're okay, Loris. With me so far, Rita? So basically, we got those in all children, and then we basically create them on a heap. We return the pointer to that child. Then we take the address of base, and then the address of base is actually a pointer to ZLD, and we just keep that. And basically, we store those as it's kind of like upcasting, I guess, in a way. Is it upcasting? I think it's upcasting. And that's it. And then because every structure shares the tag, we use tag to actually disambiguate which one it is. But if nothing precludes you from making from cheating the system, if you actually pass an ELF for a Mako object and the field, basically you're gonna return something that's garbage, because you're gonna have everything like in the wrong place. But this is in principle how it works. And I think this is for this one is including the vtable in each object, I believe. So that would be more, I think, like, yeah. So this is the field parent pointer idiom. Does that make sense? So for that case, cool. And then the other one, I think that was the fat pointer, was it? I actually didn't do. I think we have a wait. Maybe Loris will remember. Loris, remember when Alex Naskos gave a really good talk in Zig Showtime on polymorphism in Zig? Ah, sweet. So Reta, have a look at this video, because he describes everything with really good examples. If you missed it, as part of the Zig Showtime, I think it was like last year at some point, and it was really good. And so for the second, the field parent pointer, this is so common in Zig now that that you can find it in our code base. You can actually have a look at ZLD. Let me send you the link. Okay, but I don't have voice enabled, like desktop audio, so I can turn it on, but I know, but I can totally do this, but and where did they go? Ah, okay. The keyboard, you mean? Is that the one you have? Oh no, it's coming soon. Oh my god, you're horrible. I want to buy one, and I should be saving money. That's like, oh, you're the worst. This looks good. I know, he's horrible, right? So, Loris, you can get us this for Christmas. Oh, launch, okay. System 76. Yeah, rest in peace, money. Oh, but this is, oh, okay, interesting. But this is more like a standard layer, right? This is the... Interesting on the actually having two space keys. Only $285. Jesus. Oh, and is it wireless? Yeah. No, it's high speed USB. Okay. Yeah, it looks nice. I don't think I'll be able to. I tried like recently. So the keyboards I used to have, a USB hub. Yeah. Philco Majestat 2. I think Ninja. No, I didn't have Ninja. 10 keyless. Is there any other website for this stuff? No. Okay, let's go to that shop. I have 2 of those with cherry blue, I think. And the problem with a keyboard like this, after I went split, it's difficult for me to go back. It's actually, this one is slowing me down like a lot nowadays. I guess just muscle memory. Right, let me quickly have a look at this fat pointer stuff. Oh, okay, in this case, yeah, and oh, actually, I don't use wrist rests, Loris. I hate them. And I'm actually using Moonlander, so, but I'm fine without them. I don't know how I'm doing it, but I hate wrist rests. I actually hate anything other than the keyboard lying next to it. It's horrible, but yeah. I need to have a look at this, the one you recommended. Oh, this is the one you have, wait. Sweet, that looks really nice as well. So question, is this like, is it not too far a distance? Because you have like, is it the same thing here? I can use it both ways. My wrist resting on the table or hover them, depending on where I have a keyboard. If I have it at the edge of the desk, then obviously I hover them. If I have it closer to the monitor because I'm lazy, then I just put it on the table and I'm fine. And I have it slightly elevated too because it was too when it was flat, it was a bit too flat for me. So I have it like in the Moonlander style. So here's a very important question, Loris. Did you build it yourself? Like, did you actually build it? Did you do the soldering and stuff? Oh, I get it. Yeah. Actually, I had this. I had something like a. I had actually wrist pain after using ages ago. What's it called? Magic Trackpad by Apple. Oh my god, it actually gave me so. Actually, yeah, my doctor even suspected, my GP suspected I had a early onset of arthritis. He prescribed me with like, I don't know, like a massive pack of ibuprofen, and it turns out it was the Magic Trackpad. Okay. I'd love to get the actual like components and just solder it myself. I have a really nice soldering iron, but I don't have. I wish I had an excuse to actually use it, but yeah, I don't. So cool. I know what you mean, look, yeah. Although having a really cool soldering iron is really nice. What does it do? And it shows you the entire thread or something, or like this, yeah? Cool. Yeah, I noticed that. Actually, Bork is really it's a really nifty tool. I have to admit, it's really good. So I'm definitely waiting for the release, and then we should definitely package it for next OS. It's gonna be so much easier for me to use. And yeah, that's correct. I'm actually intending to stream mainly from Linux, because I think this is where most of interesting and cool work is gonna happen nowadays. Well, maybe with the exception of actually trying to work out the code signing for dilibs on Mac OS, but yeah, why would I do that if I can have it natively? Yeah, but why would I want a Mac host? You know, this is a pretty powerful machine. You're the macho man, yeah, okay, fair enough. But you know, I've got actually 64 gig. I think 3 gig is taken by the integrated GPU. I have 16 cores. I have 1 terabyte of a very fast SSD, so I think I'm good. I think it's a very nice machine. So, I mean, the GPU could be better, but I think it's this iteration. Basically, the AMD Renoir is not like, it's okay. Could have been better. Obviously, it doesn't beat M1 SoC when it comes to GPU performance. It's like M1 is insane. Okay. I think this has been some good progress. Let me go full screen. Oh. It's the camera. Yeah, I think it's the light is kind of shit, is it? Let me turn on the light a bit. Whoa, that's too much. Yeah, so okay. Right. Anyway, this has been great. Retta, have a look at the link that Loris pasted. I can find it again for you if you want. Bork links. It was cool. Yeah, it was that one. So yeah, excellent. Have a look. But basically, yeah, the approach with field parent pointer is slightly confusing, but it's basically used in ZLD and used in Zig. For the allocator, I think we use now the fat pointer approach. So that's the first one, I think, for the allocate. So that's the one where you actually have, I think, two pointers. Like a fat pointer basically carried around, right, to be able to work out what is what. And I think one of those is actually used underneath in like any vtable implementation or like C++ or any other language that's using it, like Rust, I guess. Just in Zig you have to do it manually. Yeah, so thanks everyone. Let's do some raid, and I guess so. I'm gonna have a break next week because I'm gonna be away. And I think 2 or 3 days into the week after, I think I might be able to do it maybe on Tuesday, maybe on Wednesday after Christmas. But we'll see. And then we're gonna work more on who knows, maybe we'll have some chance to actually work on. I'm going to my parents with my daughter, and then my wife is joining us a bit later because she's an MD, and you know I can work from anywhere, but she can't. So yeah, so thank you. You guys have fun too. Merry Christmas, I guess. And let's raid, and then I'm gonna ask Loris who to raid again. Oh my goodness, Twitch, are you not working? Thanks, Luke. Oh, we're gonna be in touch on in the chat though. Don't worry, the raid, I don't think it's working. It's just spinning for me for some reason. Okay. Maybe I have to refresh it. Come on, Twitch, what are you doing? Yeah, there we go. Okay. Who did you suggest last time, Loris? What was the guy's name again? Oh. Yeah, I really need to. I'm really bad at this rating stuff. Okay, we can actually, maybe we can raid Christian part. Oh, you don't see anybody who wants to raid? Okay, because there is some terminal emulator development going on. Maybe that would be interesting. We can try that.